Hi everyone, Mary here, and we are continuing with some chapter 4 problems. So here we go. Calculate the tensions in the two cords that support the 500 Newton weight as shown in the diagram when the weight is suspended in an equilibrium position. Now, and if it says equilibrium, what does that mean? That means the sum of the forces in the x direction equals 0 and the sum of the forces in the y direction equals 0. So let's take a look at what's going on, and let's begin by drawing all of our forces. So we have the, of course, force of gravity going down, and we have two tensions. This object is suspended by a rope or a cable of some sort pulling it up and to the right, and a rope or cable of some sort pulling it off and to the left. This right angle here is supposed to represent maybe a ceiling and a wall. So this is what we've got going on. Now, to the left, the only tension we have is T1, but we also have a component here of T2, whatever this cable is. So we're going to have to break T2 into components. There is going to be a horizontal and a vertical component of T2. And what's going to happen is the upward or vertical component of T2 is going to counteract the force of gravity down, and the horizontal component of T2 is going to counteract the horizontal component of T1. And by looking at those, that's how we are going to be able to calculate the tension in T1 and T2. So let's go ahead and draw our equations out and see what we end up with. So we're going to sum the forces horizontally. Those are going to equal 0, and they equal 0 because we're in a static or not moving situation. Sum of the forces vertically are going to equal 0. So horizontally, what forces do we have? We have T1 is going to equal, I'm going to call this the force to the right. So that's going to equal my force to the right. And vertically, the force of gravity downward is going to equal, and I'm just going to simply call that the force up. All right, now let's take these and throw some numbers with it or make it a little bit more expanded. So T1, we don't know. That's one of the big things we're looking for is T1 and T2. Those are our ultimate goals. The force to the right, we can figure this out because I have taken T2 and we're breaking this into vector components. If you remember the rule from geometry of alternate interior angles, if this is 60 degrees, this is going to be 60 degrees. So this triangle expanded, this is going to be a 60-degree angle. This is going to be T2, where this is my force up, and this is going to be my force to the right. So my force to the right is going to be equal to my hypotenuse, T2, and since this is the adjacent side, so this is going to be times the cosine of 60 degrees. That's going to be the sum of my horizontal forces. Vertically, my force of gravity, we actually know that. We were told the weight of this object is 500 newtons, and newtons is a force, so we don't have to do anything to that to make it a force. And the force up is this side of my vector triangle, which is going to be my hypotenuse, T2, and this is the opposite side from my angle, so I'm going to be able to use the sine of 60 degrees. Mathematically, what we're going to do at this point in time is we are then going to solve for T2. Once I have T2, I'm going to shove T2 over here, and then I can solve for T1. So let's go ahead and solve for T2. T2 is going to be equal to 500 newtons divided by the sine of 60 degrees. So T2 is going to be 500 newtons divided by the sine of 60. And when I throw that in my calculator, I get 577 newtons. That then gets pushed into here. T1 is going to be 577 newtons times the cosine of 60 degrees, or T1 then ends up being 289 newtons. And that is the tension in those two cords. All right, see you later. Bye-bye.